Dear students, in this video we will understand what is greatest integer function. This is also known as floor function or step function. In Karnataka PU board, in first PUC board exam, part D, they ask this question for 5 marks. Generally, modulus function, signum function, greatest integer function. Out of these three, any one of the functions will be asked for 5 marks in part D main. You have to write the definition, graph of the function, domain and range of this function. If you write this much, you will get complete 5 marks. I have already made a separate video on modulus function and signum function. I will leave the links. I will also give the iCards of those two videos. Please check it out. Dear students, now let us understand the definition of greatest integer function. Greatest integer function is also known as floor function, or it is also known as step function. A function f from R to R. This is also a real valued function. So the function is from R to R. Now greatest integer function f of x is always written like this. X is enclosed between square brackets. For all x belongs to R, for all real values of x, this is called greatest integer function or floor function or step function. How do we understand this? For any real number x, the greatest integer function is the, what is the value? Greatest integer, which is less than or equal to the given value or considered value x. That is what is the meaning. What is it? For a considered value of x, we can find infinite number of integers which will be less than that value of x. But out of this, we have to find the greatest integer. That is greatest integer function. What is it? Greatest integer less than or equal to the considered value of x. Now let us check this for positive and negative integral values. Now whenever x is 0, that is f of 0, greatest integer 0 will be 0 itself. That is greatest integer less than or equal to. The equality comes into picture here. So there are infinite number of integers which are less than 0. But if that itself is an integer, then that is like 0, 1, 2, 3, 4, something like that, then greatest integer value is the greatest integer less than or equal to. Equality comes into picture here. So equal to is 0. So this is 0. Greatest integer function assumes the x value itself whenever x is an integer. So greatest integer 2 is 2 itself since it is an integer. Greatest integer 3 is 3 itself as it is an integer. Greatest integer 4 is same as this. Greatest integer 6, because it is an integer, it takes the same value. Now for the negative integers, it is same for the negative integers also. Less than or equal to -1 will have infinite number of integers which are less than -1, but less than or equal to comes here. So equal to is -1. This is again -2, -3, -4 and -6. So what did we understand from this many examples? Whenever the domain element is an integer, greatest integer of those domain element will be the integer itself. Whenever it is an integer, the greatest integer value is the integer itself. That is what we have just understood now. Okay, but when it is a decimal number, since we are considering the domain to be set of real numbers, we have to check the decimal values also. So let us check that first. Positive decimal values we are checking first. Now, this we will understand with the help of number line. We just understood for 0, greatest integer 0 is 0 itself. Now for a positive value, 0.001. 0.001 is somewhere here close to 0. Now 0 is less than 0.001. Do you agree? Yes. -1 is less than 0.001. -2 less than 0.002. As we can see here, the point is here. 0 is less than this point, -1 is less than this point, -2, -3, there are infinite such integers which are less than 0.001. But out of this, which is the greatest? This is the greatest. The greatest integer function assumes this value as 0. That is greatest integer less than or equal to x. But equality comes into picture whenever our x is an integer. But whenever it is a decimal value, whenever x is not an integer, then less than comes into picture. So greatest integer less than the given x or considered x. Infinite number of integers which are less than the considered x. Out of this, which is the greatest one? Greatest integer less than or equal to x is what you have to remember. You remember this phrase, you will understand greatest integer function without any confusion. Now again 0.5. I will just write 0.5 here. You can clearly make out. 0 is less than 0.5, minus 1 less than 0.5. Here again consider this 0.5 is here. This 0 is less than 0.5, minus 1 is less than 0.5, minus 2 is less than 0.5. There are infinite such integers. But out of this, which is the greatest integer? Greatest integer which is less than or equal to 0.5. Greatest integer which is less than or equal to 0.5 is none other than 0 itself. So we considered a point close to 0. Now it is 0.5. Now we'll consider a point close to 1, which is 0.9. It can be 0.999999 also. So even if it is so, which the point is here, which is the greatest integer less than or equal to 0.99. Again it is 0. Okay. Now the moment x takes the value 1, what is our greatest integer value? It is 1 itself because it is an integer. The moment it becomes an integer, the greatest integer value assumes the integer itself. Now what did we understand? It was for 0, it was 0. From 0 till 1, the greatest integer value was 0. But the moment it became 1, the greatest integer value is 1. So in this interval, it is 0 less than or equal to x. Whenever x is in this interval, it becomes 0, x is 0 and it increases to 1, but it is not 1, less than 1. In this interval, the greatest integer value is always 0. You check here, for integer we got an integer. Even for a decimal values, we are getting integer only as the answer. Which is that integer? It is this 0. Whatever the integral part, that is only we are getting now. Okay, let us check furthermore. Now, next we will check for the value which is little more than 1. 1.001. We will check for this 1.001. Now, greatest integer 1 is less than 1.001. I am sure you will all agree. 0 less than 1.001. And so on. This will go on. That means 1 is less than this point. Dear students, we are considering only integers. It is because of the definition itself. Greatest integer. We are not considering the real values between this. So, greatest integer less than 1.001. Which is the greatest integer less than 1.001? So, it is 1. Integer less than 1.001. It is 1, 0, minus 1 and so on. But out of this, 1 is the greatest. So our function assumes this value. Now we'll consider 1.2, 1.3, 1.4, 1.5, whatever the value is. The greatest integer less than or equal to will be 1 only. This will be 1 only. Again, I'm considering a point which is very, very close to 2, but not 2. 1.96814. Again, it is the integer, greatest integer which is less than this value will be 1. So, what are we getting? We are writing this integral, whatever the integer here is, that is becoming our answer when it is a positive value. But for a negative value, it changes. Okay, now if it is 5.6, 5 is less than 0.6, 4, 3, 2, 1, 0. So many infinite points are less than 5.6. But out of all that, greatest integer which is less than 5.6 is 5. Similarly, for 7.1, the greatest integer happens to be 7. Greatest integer less than or equal to 7.1 is 7. Now, these are all for positive real values. Now, let us check for negative real values. Okay. Now, see, we already know that this is 0. If we go to left side of 0 in number line, the value decreases, correct? As it goes to the left, the value decreases. So, now we are considering minus 0.001. Minus 0.001 is somewhere here, very close to 0. So, if it is very close to 0, look at the number line, which is the integer which is less than minus 0.001. Minus 1 less than minus 0.001. Now, minus 2 is also less, right? Minus 2, minus 3 and so on. There are so many integral values. which are less than minus 0.001. Out of this, which is the greatest? Out of this, minus 1 is the greatest. So the answer is minus 1. Now let us consider minus 0.5. Minus 0.5 is somewhere here, correct? Now again for minus 0.5 you consider the greatest integer which is less than minus 0.5. Again minus 1 is less than minus 0.5, minus 2 is also less than minus 0.5, minus 3 is also less than minus 0.5. So out of this the greatest one is minus 1. Again we are checking from for 0 it was 0. As x value decreases, integral value is minus 1 only. And now we'll check a value which is very close to minus 1 but not minus 1. Minus 0.9 or 0.99, minus 0.99 or minus 0.99999 also. The greatest integer value remains to be minus 1. And again for minus 1, we already know it is minus 1. For integer, it is an integer itself. Now, the moment it decreases further from minus 1 to minus 0.001, the point is here, minus 0.001. This is the point. Now, we cannot consider minus 1 because minus 1 is greater than this value. So what we have to consider? Minus 2 less than minus 1.001. Again, minus 3 less than this. Minus 4 less than this. And so on. This goes on. So out of this, which is the greatest integer? Greatest integer which is less than this value will be minus 2. The moment it decreases from minus 1, the greatest integer less than or equal to will be minus 2. Again, you consider any point here, here. For all these points, even for minus 2, the greatest integer value will be minus 2 only. Again, you check for minus 1.96814. This is minus 2 only. As for minus 2, we already checked it is an integer. Now, so what are we getting here? When our domain element was a positive fractional value, we wrote only this integral. Logically, we got that integral as the value. But what are we getting for negative values? If you see, if it is minus 1 or minus 1.96 something like that, we are getting an integer which is less by 1. That is, if minus 1 point something, our answer is less by 1, that is minus 2 is what we are getting. Let us check minus 5.6. There are infinite integers which are less than minus 5.6. That is minus 6, minus 7, minus 8, minus 9, minus 10 and so on. Out of this, which is the greatest? That is minus 6 is the greatest integer which is less than this. If you check the number line, you will understand this better. Again, minus 7.1. Infinite integers are less than minus 7.1. Out of those integers, which is the greatest? Minus 8, minus 9, minus 10, minus 11 and so on. Out of this, the greatest integer which is less than or equal to, that is here equality doesn't come. Greatest integer which is less than minus 7.1 is minus 8. Dear students, hope you have understood the logic behind writing the greatest integer value. So whenever it is an integer, the value of the function is itself. But whenever it is a positive integer, it will always assume the value which is the integral part of the decimal number. Whenever it is a negative value, it will always assume the one value lesser than the integral value. That is what we can understand from this. Now let us check the graph of this function. To check the graph of this function, now we already know that for all integral values, it takes integral values only. So let us mark those points now. Now in the graph, we have just understood it takes all integral values. So for 0, it assumes 0. And for 1, it assumes 1. And for 2, it is 2. For 3, the greatest integer value is 3 itself. And for 4, it is 4 only. And 5, it is 5. And for 6, it is 6. And so on. For minus 1, it is minus 1. For minus 2, it is minus 2. Minus 3 is minus 3. Minus 4 is minus 4. Minus 5 is minus 5. And for minus 6, it is minus 6 and so on. Now, for integral values, we have already written the points. Now, when it is of decimal value, see, we just checked for little more than 0. What did we check? Even for 0.001, what was the greatest integer value? It assumed the value 0 itself. It became 1 when it is 1. For all other value less than 1, it was, for all these points here, our y value remained 0. Y value was 0 itself. For it is for 0.5, 0.75, whatever the value was in between 0 and 1, y was 0 only. So our points, if we join the points, we get a line here. And for 1 it is 1, right? So our graph does not exist here. There is no graph there. So we have to write a gap here. We have to show a gap here, which is very much important because there is no point there. For 1 it is 1. Again we have understood for 1, 1.1, 1.2, 1.3, 1.9 till it is 1.999999 and so on. What was the greatest integer value? It was 1 only. So we got this line by joining. The moment it became 2, the moment x is 2, the greatest integer value, the y became 1. So because it was 1, 1, 2, 2, 3, 3 and so on. The moment it is 2, the graph suddenly jumped here. There is a gap here and this point does not exist. It is not part of the graph. So again from 2 to 3. For 2 it was 2 till it is 3. The graph is here. The value assumes 2 only. It keeps assuming the value 2, 2, 2, 2. But the moment it becomes 3, the point jumps to, or the y value jumps to 3. So it repeats the behavior. That behavior is repeated. The moment it is an integer, it assumes the value itself till it is less than the integral value. That is, it is less than 6. It keeps assuming 5, 5, 5, 5, 5 as the value. The moment it becomes 6, it is 6 here. And so on. This goes on. Now in the negative side, you check in the negative side. Here the point is, you check this point. There is a gap here. Why is gap there? Why do you think there should be gap? This point is, it is 0. X is 0, but the y is minus 1. In greatest integer function, we know that it always takes the point 0, 0, minus 1, minus 1. It never takes the value 0, minus 1. It does not take. So this is a gap because this point is already marked here. This is a gap. Now, whenever it is less than 0, whenever x is less than 0, y always takes the value. What is the value it takes? Minus 1. It is minus 1 till it is minus 1. The y always takes the value minus 1. So joining the points will give us a line here. Again, the moment it is minus 1, it is minus 1 only. So now the point is already here. There is no point for this. That is, there is no point like minus 1, minus 2. There is no point like that in the graph. So this is a gap here. Again, between this two, for minus 2, we already know it is minus 2. Between minus 2 and minus 1, the greatest integer value always assumes minus 2. Again, this part we already have checked. This is a straight line. Again, this point does not exist. Join. Similarly, it repeats the behavior down below also. You just have to remember which is the point. Now, this looks like a step. So this function is also called as a step function. There are so many students who make this mistake. They either miss out this point or they interchange this point. The filled point, the existing point and the gap, they interchange, they get confused. So if it is a situation, always mark the integer points 1, 1, 2, 2, 3, 3. You just mark those points. Then the other point has to be a gap. This way you can avoid confusion while drawing the graph. So each and everything has to be specified. If you write neatly, you will get complete 5 marks for this. Now, domain and range. Let us check the domain. What is the domain of this function? Since this is a real valued function, it is defined on set of real numbers. But while talking about the function, we never said for any point of a real value, the graph does not exist or we cannot define the function. Now, something like that we did not tell. So, what is the domain? It is the set of real numbers. And what is the range of this function? Range is whenever we give any value, whenever we give any value to the function, the greatest integer value function always assumed the integer. It always got integer as the answer. As the very name of the function says, greatest integer function, or that as the definition says, greatest integer less than or equal to x. So it is always an integer that we get as the answer, or that we got as the answer. So range of the function is set of integers. Now this is for the first PU students. Now for the second PU students, if you check, look at this. The graph is continuous from this point to this point. The moment it takes the integral value, the graph jumps here. There is a gap here. There is discontinuity here. Again, from this point again it is continuous. Again there is discontinuity, jumps here. So it is discontinuous at all integral values. So second PU students, you please note, it is discontinuous at all integral values. Dear students, if you have any doubt on this, please let me know in the comment section.